In this lesson, we're going to explore different properties of polygons, what make up polygons, and just talk a little bit about some of the characteristics of polygons. So for the launch activity, I'm not going to go over this in this video. We did this in class, so don't worry about that right now. This just is a review from the notes yesterday. So a polygon is a closed figure in a plane formed by connecting line segments, endpoints to endpoint, with each segment intersecting exactly two others. So if you look at these, you have polygons. Closed means that they are sort of a closed figure. If you were to fill them up, stuff would not leak out of them. They're formed by connecting line segments. So you can see these three are made up of line segments. This is closed, but both of those are made up of line segments, or have some curves in them, so they are not polygons. This is just a line segment, so it's not a closed figure. So again, polygons are typically going to have these types of shapes. So each line segment of a polygon is called a side. So if you look at this, it says 1, 2, 3, 4 sides. So that's a quadrilateral, and then this polygon right here is a triangle, and then so forth. We'll talk about how to name those polygons. Each point where two sides meet, so right here, this is called a vertex. So these are all your vertices, and you can kind of think it's like the corner of the shapes. So it's wherever two sides meet, that is what's called a vertex. So naming polygons. We classify polygons by the number of sides it has. So we would want to call polygons by those names. So some of these polygons you've heard of before. You have a 3-sided polygon. That's called a triangle. 4-sided is a quadrilateral. 5 is pentagon. 6 is hexagon, and so forth. You'll notice that once you get up to higher than 12, we no longer refer to it as any special name. We just call it a n-gon. So for instance, if you had 25 sides, you would just call it a 25-gon. There's no special name like hexagon or heptagon or anything like that. So again, looking at this polygon here, we would call this polygon A, B, C, D, E. Typically, you're going to want to name these polygons by naming consecutive angles. So A, B, C, D, E. Consecutive angles and consecutive vertices mean that they go in order. You would not want to say A, C, B, D, E. That jumps around. A, C, B, D, E. They are not in consecutive order. So you have consecutive sides. Those are sides that are touching. You have consecutive angles and consecutive vertices. Those are angles or vertices that are where two consecutive sides meet. So again, this would be pentagon A, B, C, D, E. This would be triangle A, B, C. Now, another thing that we take a look at when we start talking about polygons are diagonals. Diagonals are line segments that connect two non-consecutive vertices. So if we look at this picture over here of this quadrilateral, diagonals are line segments that connect, for instance, D, F, or E, C, or E, G. They're connecting non-consecutive vertices. Things that connect consecutive vertices are just the sides. So you would not name a diagonal as EF because EF connects two consecutive vertices, which make it a side. So diagonals are used to help us figure out whether or not a polygon is convex or concave. So looking at this, it says a polygon is convex if no diagonal is outside the polygon. So if you look at these polygons, the diagonals here are all inside the sides, so they're inside of the polygon. Whereas if you look at the other polygons over here to the right, they have diagonals that connect non-consecutive vertices here, or there, those diagonals are outside of the polygon. That makes them concave. So a convex polygon is where diagonals are all inside. Okay, so diagonals all inside the polygon. A concave polygon is where there is at least one diagonal is outside. Okay, and that is how you define whether or not something is a convex or concave polygon. Now, when we are dealing with polygons, we have to be able to figure out whether or not they are congruent. And so what we know is that two polygons are only congruent if and only if they're the same size and shape. That means all the corresponding sides must be equal, and all the corresponding angles must be equal. Okay, again, that's what this states right here. All corresponding sides are congruent, and all corresponding angles are congruent. So the statement allows us, since it's an if and only if statement, it allows us to switch the order. So if polygons are congruent, then all corresponding sides and angles are congruent. But that also allows you to say if corresponding sides and angles are congruent, then polygons are congruent. So if you look at this over here, we have two polygons, and what it says is we have polygon camp is congruent to polygon site, or quadrilateral camp is congruent to quadrilateral site. And so when you're naming or creating a congruence statement for polygons, what you have to do is make sure that corresponding sides and angles line up. So if we look at this, we list angle C first. So angle C has one tick mark. Now we list angle S first. The reason we list angle S first is because it has one tick mark. It corresponds to angle C. It is congruent to angle C. Then we go A, which has two tick marks. That means you have to list in the other polygon I second. You could not go S, E, T, I. If you did that, E does not correspond with A because E has four tick marks, A only has two. So again, you have to pay attention to what piece corresponds, or what angle corresponds with what angle, and what side corresponds with what side. So if you look at this, you have side CA and SI. SI has one tick mark, CA has one tick mark. So again, they are corresponding. So if you look at this example, it says which polygon is congruent to A, B, C, D, E. So if we're looking at this, we would need to find out first which angle corresponds with A. Well, we know angle J, N, and S would correspond with angle A. And then if you look at this, you can kind of visualize that if this were to rotate, so if we copied that and then just sort of rotated it a little bit, okay, you'd be able to see that AE corresponds with JH, JH in this case. And in this case, if you're looking at this, you would see that EA has one tick mark, JH has two tick marks. Since those are corresponding sides, they should be congruent in order for them to be congruent. But because JH is not congruent to AE, that means that this polygon is not congruent to ABCDE. So if you go through this and look, you'll notice that if you look at all the corresponding pieces, you'll see that B should correspond with T over here. Well, T does not have a tick mark in that angle, therefore we don't know if T is congruent to B, so we can't say that's not congruent. So the congruent polygon is going to be this one right here. And you would say angle ABCD, or polygon ABCDE, is congruent to polygon NPQLM. So the last few things we'll look at, we have perimeter. Perimeter of the polygon is equal to the sum of the lengths of its sides. So in order to figure that out, to figure out the perimeter, all you do is you look at the length of each side and you add them up. So we have the perimeter would be equal to, for this polygon or this quadrilateral over here, would be 5 plus 5 plus 15 plus 12. And so that would give you 27 plus 10, which would be 37 centimeters. So the perimeter of that polygon is going to be 37 centimeters. Last few things that we need to take a look at are some different special types of polygons. If you look at these, we have equilateral polygons. So equilateral polygons, if you look at this, these polygons all here are equilateral, and these ones over here are not. So if we take a look at this, you'll notice that for equilateral polygons, all the sides are equal. Okay, so in this case, equilateral polygons, all sides are equal. Equiangular polygons, you can probably take a hint from the previous one. Equiangular means that all angles are equal. And finally, if you look at regular polygons are going to be polygons where all angles and sides are equal. And so those are just 3 special types of polygons. We're going to take a look at a couple problems here. So it says if the perimeter of the quadrilateral is 20 centimeters, find x. So if we take a look at this, you see we have a length of 4, a length of x plus 2, a length of 3x. These two sides are congruent, so this is also going to be 3x. So you have x plus 2 plus 4 plus 3x plus 3x equals 20 as your perimeter. We'll combine like terms. 3x and 3x is 6x plus another x is 7x. 2 and 4 is 6. That's equal to 20. Subtract 6, you get 7x equals 14, and so you get x equals 2. If you look at this picture, it says what's wrong with this picture of equilateral pentagon, and then there's a typo here. That should not say A, B, C, D. It should say A, B, E, D, C. And the problem with this picture is that equilateral, this means all sides are equal. But in the picture, all the angles are equal. So this is actually an equiangular pentagon instead of a equilateral pentagon. So go ahead and start working on the homework. If you have any questions, make sure you come to class the next day to have those answered at the beginning of the class.